So what do we do with significant figures when we do calculations? Because when we use numbers in a calculation, we need the result of that calculation to reflect the precision that the measurements were made with originally. The calculator does not understand the concept of uncertainty in significant figures, and so it will sometimes just give you a big mess of digits. Not all of those are significant or meaningful, and so we need to learn what to do with the significant figures so that we can round those things appropriately. When we have calculations with multiple steps, we save our rounding for the very end. We're not going to do this part and round it off, and do this part and round it off, and then use those two rounded numbers right away in a calculation and then round it off, because that introduces error as well. So there are two categories of operation. There's multiplication and division, and there's addition, subtraction, and there's different ways that we handle significant figures for each. So for multiplication and division, the result is going to have the same number of significant figures as the factor with the fewest. So we'll do some examples here so we can see what that means. So here, this first example, 5.02 times 89.665 times 0.10. You do that on your calculator and you get this result. What this rule is saying is that we're going to look at the numbers that we multiplied and we're going to figure out how many sig figs are in each of those. So in 5.02, how many significant figures does that have? That has 3. So this one's got 3, and 89.665, that has 5. That one's easy, no zeros. 0.10, 2. Leading 0 is not significant. The trailing 0 is significant because there's a decimal point. This is the hard part. Which of those is smaller, 3, 5, or 2? 2. That was a trick question. 2 is the smallest number, right? So 2 is how many sig figs we should have in our answer. So there's the 4 and the 5. The 5 is the last digit that we're going to keep. That's the digit that has uncertainty in it. So we're going to express this answer as 45. And that's our rounded answer. The best thing to do the calculation. Your calculator gives you this big old messy number. Write everything down. Then go back and identify how many sig figs should I have, round it off, and then write the rounded number next to it as your answer. Any questions about that one? Let's do the one at the bottom. Okay, 5.892 divided by 6.10 equals, and that's what the calculator gives us. So we have to look at the two numbers that we got the result from. 5.892, how many sig figs? 4. 6.10, 3. Okay, so 3 is smaller than 4, so we're going to keep 0.965. We're going to keep that third digit. Now we need to look at the next digit. The next digit is a 9. So if the next digit is 5 or greater, we're going to round up. If it's less than 5, we round down. Because 0.9659 is closer to 0.966 than it is to 0.965. So we're going to say that our answer here is 0.966. Yes?
Do we have things like this on our homework?
There should be, yes.
So when we enter it in, because I know like math and stuff like that, it's really particular on how we enter it in. Do we put the 0 or do we not put the 0 before the decimal?
That's a good question. I don't think it's going to be picky about that.
Okay.
It will be picky about the number of significant figures. If you put in this whole number, it would at least give you a comment about how your number of significant figures are not right. In Chapter 2, There's a lot of questions specifically aimed at, are you understanding significant figures? And there you have to get just the right number. In later chapters, if you're off by 1 or 2 significant figures, or if you round wrong, it may give you full credit, but it'll say, your answer is really close, you must have rounded or used the wrong number of significant figures. Good question. Any other questions? Yes?
Yeah, how is 6.103 significant zero?
How is 6.103 significant figures?
Yeah.
Okay, so it's the trailing zeros that really get us into trouble and are confusing. The rule is that the trailing zeros count if there's a decimal point. So this number has a decimal point, so any trailing zeros that are there, we're going to count. If there's no decimal point written in the number, like say we had the number 5,500 with no decimal point, those zeros are ambiguous. And so we're going to take the most conservative approach and say they're not significant. If we put a decimal point here, oops, if I put a decimal point there, then they magically become significant. So we're very precise in how we write our numbers. Because this, with the decimal point, implies that I know that number, I measured it to the nearest one. You know, so maybe that's 5,500 miles. That wasn't an estimate, I actually measured it, and it's between 5,499 miles and 5,501 miles. That's my intent in writing that number. If we take off the decimal point, a scientist looking at that says, well, that's to the nearest 100. You mean between 5,400 and 5,600. That's a big difference in precision. The first one with the decimal point saying we measured it to the nearest mile, and here this is to the nearest 100 miles. Does that help? Any other questions? So when we round, which we just did some rounding, but here are the rules for rounding, we're only going to use the first digit that's getting dropped to round. We're not going to start at the end and round up, down, all the way along. That's silly. We're just going to take the first one, okay? Ignore everything to the right. If the digit that you're dropping is 4 or less, round down. If it's 5 or greater, round up. And again, we're only going to round the final answer. So let's do some more examples. Get out your calculator if you haven't already. So perform each calculation to the correct number of significant figures. So what we should do is we do the multiplication or division, whatever it is, on our calculators first, and then write everything down that the calculator shows you. So I'm going to do that, and you do that too, and hopefully we'll all get the same answer. So I got 0.067556375. Did anybody else get that? Yes, thank you. So if you're doing this, at home by yourself, do it twice and make sure you get the same answer. I'm going to do it once and then ask if anybody else got it, and so we'll know that, yeah, that's probably right. So do the math, write down what the calculator says. Then we have to go look at where did this number come from. And we identify in each of these numbers how many significant figures. So 1.01, how many sig figs? 3. 0.12, 2. 53.51, 4. 96, 2. Sometimes with a whole number, you think, oh, well, that's a whole number. That's an exact number. Not necessarily. Only if you have a specific reason for believing that it's a counting number or something like that. If it's a times 12 pencils, well, yeah, that's obviously a counting number. Here we don't have any units yet, and so we assume it's not exact. 3242, Okay, 2 is the smallest number of digits. So then we're going to round our answer to 2 significant figures. These zeros don't count. Leading zeros are not significant figures. Okay? That's a common mistake. People will round this off to 0.1, 0.1, thinking, oh, there's 2 significant figures. The zeros don't count. We're going to keep the 6 and the place that the 7 is in, and then we have to look at the next one. It's 5. 5 or greater rounds up. So we're going to write this as 0.068 with 2 significant figures. Any questions? Yes?
Would it matter if we put the first zero before the decimal or not? So, oh, you said you wanted to do that.
I think it's always a good idea. I really need to go back and change that previous slide and put a 0 in there. I always put a 0 before my decimal point. It helps to draw attention to the decimal point. It looks kind of naked to me without it.
Thank you.
We know what you mean if you leave the 0 off, but I would encourage you to put the 0 in there. Any other questions? So let's do this next one. Again, we're going to do the math on the calculator first. 56.55 times 0.92 divided by 34.2525. And the calculator is showing me, where is that darn decimal point? 1.51 8896431. Anybody else get that? Okay. Okay, so that's what the calculator says. But chances are good that a lot of those numbers are really pretty meaningless. They're basically artifacts. They don't really mean anything. So we look at where we got the number. 56.55, how many sig figs? 4. 0.920, 3. The leading 0 doesn't count. The trailing 0 does because there's a decimal point. 34.2525, 6. So 4, 3, 6. 3 is the smallest. So we're going to keep 1, 5, and we're going to keep this 1. That's the last digit. That's the digit that has uncertainty in it. We look at the first one that we're dropping off. Okay, so that's 5 or greater. We're going to round up and call this 1.52. Any questions? Okay, so what do we do with addition and subtraction? Well, first in words. The result carries the same number of decimal places as the quantity carrying the fewest decimal places. This rule is different. Most students find the multiplication division rule easier. And the good news is that that's mostly what we do, is multiplying and dividing. The addition subtraction rule is a little tricky sometimes. Let's look at this example and to help us understand what this is, why it is this way. So in any measurement, there's an uncertain digit. We include all the certain digits, we read between the lines, and we estimate one. Where is the uncertain digit? At the beginning? In the middle? It's at the end. It's always the last digit. So I'm going to do this a little differently. Oh no, that doesn't show up very well. Never mind. I'll just do it the same. So 5.74, the 4 is uncertain. I'm going to underline that. 0.823, the last digit is uncertain. 2.651, the 1. Those underlined digits are estimated. There's uncertainty in them. So let's add these up and see what the calculator says. 5.74 plus 0.823 plus 2.651. 9.214. So here, We did it on the calculator, but now let's think about how we would do it if we weren't using the calculator, if we were just using our brains. This is lined up so that we could add it without a calculator. We would take 3 plus 1 and get 4. The 3 is uncertain, and the 1 is uncertain. Is the 4 uncertain? Yes, it is. Because this 3 could be, maybe it really should have been a 4 or a 2. That makes anything involved with it uncertain. So the 4 is uncertain. Let's look at the next row. Here we have a 4 that's uncertain, and we're adding a 2 that we're sure of and a 5 that we're sure of. And those are going to add up to 11, and the 1 gets recorded here. Is that certain or uncertain? That's uncertain. So I'm going to underline that one also. Here, 7 plus 8 plus 6. The sum of those, is there any uncertainty in that? No. And anything to the left, any more columns, are all going to be certain. So then let's look at what we've got down here. We have a certain 9, a certain 2, an uncertain 1, and an uncertain 4. We only want one uncertain digit. If we're uncertain about the hundredths place, we really shouldn't be writing anything down in the thousandths place, right? So we're going to keep the 9, the 2, and the 1, and we're going to record this as 9.21. And again, we're following the rules for rounding. The 4 is less than 5, so we round down. Any questions? Yes?
Because of the assembly of the number 4,
Mm-hmm.
how it carries over.
Mm-hmm.
I mean, you can carry over with the math or not?
You mean carrying the 10 over?
Right.
No.
No.
So the question is, here we had the 4, 2, and 5, those added together to make 11, and the 10 got carried over. We're not going to carry the uncertainty over into that. So how would, this is, lining things up, looking, okay, where's the uncertainty, and figuring it all out. Do we have to do it this way every time? No. So how do we apply the rule here? Well, we're going to look at these numbers and count decimal places. Decimal places are the digits to the right of the decimal. So 5.74 has 2 decimal places. 0.823 has 3 decimal places. 2.651 has 3 decimal places. So 2 is the smallest number of decimal places, and so our answer will end up with 2 decimal places. This is very different than multiplying and dividing. Multiplication and division, we're looking at number of significant figures. Here we're looking at number of decimal places. Let's do the other one. 4.8 minus 3.965. So I'm just going to go ahead and do that on my calculator. I get 0.835. 0.835. So just using the rule, how many decimal places should the answer have? Should have the same number of decimal places as the one with the fewest. Neither of those numbers has 2 decimal places. Not sig figs, decimal places. How many decimal places does 4.8 have? 1. And 3.965 has 3. So this should have 1 decimal place. So we would then round it to what? 0.8. Now let's also look at how the other method works with that. So the 8 has uncertainty, and this 5 has uncertainty because they are the last digit, right? So we're subtracting 5 from something we have no clue about. So we're assuming it's 0, but we really have no idea. So is this 5 down here certain or uncertain? That's crazy uncertain. So that's uncertain. What about the 6 here? We were certain about the 6, but what are we subtracting it from? We don't know. That makes this 3 uncertain as well. Here we've got an uncertain 8, we're subtracting 9, so this place is also uncertain. Over here, 4 minus 3, those numbers are both certain, and so we are going to be certain about that ones place. It ends up being a 0. But we're always going to keep the first uncertain digit. In this instance, the first uncertain digit is the only significant figure. So here, if we were using the multiplication division rules, we'd come up incorrect because this number has 2 sig figs and this one has 4, and yet our answer only has 1. And sometimes, depending on the numbers in adding and subtracting, they can kind of play tricks and you can end up with a lot more significant figures than you started with. It just depends on how the numbers work out. Any questions? So, some more examples. These are a little bit more complicated and they're not stacked up. First thing is to just do it on your calculator, like you'd never heard of that nasty thing called significant figures. So my calculator is showing me 7.588. Anybody else come up with that? Okay. When you're first doing these problems, you may need to take these and stack them up. That's fine. So 7.588. Let's apply the rule. We only have adding and subtracting here, so we're counting decimal places. 2.18 has how many? 2 decimal places. 5.621, 3, 1.5870, 4, that's a trailing 0 with a decimal point, 1.8, 1. So 1 is the smallest number of decimal places. So we're going to round our answer to 1 decimal place. That's the 10th place right here. 5, we have to look at the next digit, that's 5 or greater. We round up, and we're going to say that the answer is 7.6. So just kind of an illustration of this kind of process. So say we had a car, a small car, and it weighed about 2,000 pounds. Did we put it on a scale and weigh it? No. This is a ballpark guess that about a ton, okay, weighs about a ton. And so now we're going to put a newborn baby into the car. The baby, oops, this is my daughter Emily when she was newborn. She weighed 8.5 pounds. So if you add 2,000 pounds and 8.5 pounds, the calculator is going to tell you 2,008.5 pounds. But can you really say that that car weighs exactly 2,008.5 pounds with the baby in the car? No, because you didn't know the actual weight of the car very well. So looking at this 2,000, these zeros without a decimal point, these are ambiguous. We're not sure if they're really significant figures or not, so we're going to assume the worst, and we're going to say, well, yeah, you were guessing at this, and you're thinking between 1,000 pounds and 3,000 pounds. So when I report the weight of the car with the baby in it, and I say 2,008.5, that suggests to people that I know it to the nearest half of a pound, or the nearest tenth of a pound, and that's ridiculous. So Significant figures will tell us that we should record this. I didn't leave myself any room. That we should say, okay, the car still weighs 2,000 pounds. And that might bother you. Well, how can it still weigh 2,000 pounds if we put a baby in it? The baby is such a small amount compared to the whole mass of the car, and our mass of the car was such a wild guess that the mass of the baby really doesn't matter. Does that make any sense? So you'll have some times where you're adding or subtracting something and it doesn't actually change the number, and you're like, how does that work? Well, think of putting a baby in a car. Some of these things, they just come out randomly, and some of them are good and some of them are not so good. I'm not so thrilled with that one. Anyway, let's go on to B. So 7.876 minus 0.56 plus 123.792. I'm getting 131.108. 131.108. Generally in science, we tend not to use commas. Okay, so like thousands and millions, we often separate every 3 digits with a comma. We don't do that much in science. And we want our decimal points to be visible. So occasionally, my decimal points might look kind of like a comma. But I almost never write commas, so it's a decimal point. If a number is big enough that I feel like I need commas to see what it is, I'm going to put it in scientific notation, and then I don't have to worry about the commas. So that's kind of a on its side comma-looking thing, but I meant that as a decimal point. Okay, so look at the numbers. Which one has the fewest number of decimal places? The 0.56. It has how many? 2. So our answer should have 2. So what are we going to round it to? The hundredths place, so 131.11. Trying to make that look like a comma. I mean a period. Okay, any questions? What do you do if you have a problem with both types of things? It happens. Thankfully not a lot, but it does. So you've got a mixed problem. You've got multiplication and or division along with addition and or subtraction. If there are parentheses, do the steps in the parentheses first. And you have to pay attention to order of operations sometimes. Look at the number of significant figures in that intermediate answer. Don't round it off, but identify the significant figures. Finish the remaining steps, and then round the final answer. We don't round the individual steps, we're only going to round the final answer. So we'll do some examples here. So 3.897 times the quantity 782.3 minus 451.88. Okay, doing this on your calculator, you could use parentheses and just do it left to right and come up with the right answer. But what I want to do is I want to start with what's in the parentheses and do 782.3 minus 451.88 and press the equal sign and see what that is. I'm going to write that down. It's 330.42. I'm just going to leave it sitting in my calculator. Then we need to look at these guys and see, okay, this was subtraction, so we're looking at number of decimal places. This one has 1 decimal place. This one has 2. So our answer should have 1 decimal place if we were going to round it. So I'm going to underline that uncertain digit. Everything after that is not a significant figure. Okay? I'm not going to get rid of them yet, though. We're going to leave it in there. Now, on my calculator, I still have 330.42 in the display. Now I'm going to multiply by 3.897. And then I'm going to write down the answer. So, gosh, I hate this calculator. The decimal point is almost invisible. 1287.64674. 64674. That's what the calculator says. Anybody else get that? Okay. So we looked at this number, and we decided that that's where the uncertainty is. This number is multiplied by that number. So the rule for multiplying is we look at number of significant figures. This one has 4 significant figures. Let's write that down. So this one has 4 sig figs. 330.42, if we rounded it, how many would it have? 4. It would also have 4. So 4 and 4, those are the same. So we're going to keep 4 in our answer. We look at the next one, say, oh, we have to round this up. That's going to be 1288. Any questions? Okay, let's do the next one. So this one we've got 4.58 divided by 1.239. And I'm going to write down what the calculator says. 3.6965294559. Gosh, that's a mess, isn't it? How many significant figures should that number have?
3.
It should have 3. 4.58 has 3 significant figures. 1.239 has 4. This is a division problem. We're looking at number of significant figures, not number of decimal places. So 3 is the smaller. So we keep the 3, the 6, and the 9 would be the uncertain digit. That's the last one we would keep if we were going to round, but we're not going to round it yet. That is still in the display of my calculator, and then I subtract 0.578, and I get a result 3.118529459. So now I can look at that last operation that I did. This was subtraction. It was this messy number minus that one. When we're adding or subtracting, we look at number of decimal places. How many decimal places does this number have that are significant? Yeah, 2. The 6 and the 9. This is the uncertain digit. That's where the significant figures stop. Yes, all of those are there, but we're not going to count them. So this is 2 decimal places. That one's 3. So our answer should have 2 decimal places. 311. We're going to keep the 1. We're going to drop the 8. That's 5 or greater, so this is 3.12. Any questions?